Hey, what's up? So this is the first video for advanced physical science, and I've got a few housekeeping items that I want to go through about your daily videos that you're going to get when you're at home for hybrid, once you're not day to go, or if you're at home distance learning. So you will watch the daily lecture, which I'm going to really work hard to keep these all shorter than 20 minutes, and you'll need to watch the whole thing because that's what I'm going to use to take attendance. So just like if you were here in person, you wouldn't be able to avoid listening to me. In order to be counted present, you'll have to watch the whole video. But the good news is these are going to be so interesting that I wouldn't have to track you watching them because I know you won't be able to click off it once you start watching. So hopefully you learn some things. Today we're going to be learning about the metric system, and we're going to be doing an activity called metric estimation. So I'm going to be giving you some tips and tricks for learning how to do that. So again, you'll just watch the video for today, and by watching it, you'll automatically be marked present. Every day you have to watch that video the day of, because the next morning I'm going to look and see who watched it, and that's how I'm going to take attendance. Otherwise, you'll be absent. As far as the daily assignment goes, what you can do is complete the daily assignment, and then if you're going to be in person because you're doing hybrid, you can show it to me the next time that you're in class. We'll have some check-ins on your packet. So you just complete it. You don't have to upload anything or take a photo or anything like that. If you are full distance learning, then what you're going to want to do is upload a photo of your completed assignment from your packet when you're done. And every day there's one assignment pretty much in the packet. So again, today is metric estimation, so we're talking all about the metric system, and it's something you've talked about before. So I don't think this is going to be too tough for you to understand, but hopefully I can remind you of some things that are helpful and help you start thinking in the metric system. That's my goal, is that you wouldn't be converting, but that you would be thinking in the metric system. So when you see something like it's 37 degrees outside Celsius, you would say, oh, wow, that's like body temperature. Or when you think of a meter, you automatically think, oh, that's about as long as a baseball bat. Or when you would think of a gram, you would think, oh, that's about like a paperclip. So you automatically think in the metric system. So let's talk about what we might want to measure. So I got this little table here. We could measure length, and we will do that a lot in this class. And the tool that we will use is a meter stick. I have one. I'll show it to you in a second. And the base unit in the metric system is appropriately the meter. And in English, it's the foot. All right, so a meter is actually closer to a yard as far as conversion goes. I think it's like 39 inches or something. The one that I know is there's 2.54 centimeters in an inch. But what I like to do is if I want to measure in inches or feet, I'll use a regular ruler. And if I want to measure in meters, I will use a meter stick. So here's a meter stick right here. So if you look at the meter stick, you can see that it's got 100 numbers on there. Those are centimeters. Cent means 1/100th. So like a cent is 100th of a dollar. Centimeters are the numbers, right? This whole thing is 1 meter. And then the little tiny ticks are for the millimeters, which is 1,000th of a meter. So these are accurate enough to measure millimeters really for you. And so generally speaking, we're going to measure things like a classroom in meters and smaller things in centimeters. Those are the two that we're going to use the most, but the base unit with no prefix is the meter. Right? What about measuring volume? Okay, usually for solid volume, I'll just use one of these. When I say solid volume, I mean like a cube, right? And so it's either going to be in cubic meters or cubic centimeters. You've probably heard that cc's before. Like maybe you got a dirt bike that's 250 cc's. That means that the engine block is 250 cubic centimeters. When you say cubic, that's like length times width times height. That's a cube. So if you had a box like this, by this, by this, that was like an aquarium, that would be a cubic meter of water. Okay? A cubic centimeter is way smaller than that. it's like one of these wide and long and high. And a cubic centimeter is actually the same thing as a milliliter. And a milliliter is 1/1000th of a liter. And that's actually what I really want to measure in most of the time in this class, because usually we're doing liquid volume, which we do in the metric system in liters, and we use a graduated cylinder. Like that should have 1L. Well, maybe it was 2. So graduated cylinder is this guy right here. And a lot of people just kind of call every single piece of science equipment a beaker, but they have names, and the graduated cylinder is the one for measuring volume. A beaker just holds a liquid, but it doesn't have any lines on it to measure. This is graduated, which means it has lines on it to measure. So what you're going to do when you want to read a graduated cylinder, and this is probably a review for you, is you got to put it on a level surface. Okay, so I've got mine down here on the tabletop. And then what I'm going to do is try to find this little bubble at the water level. That's called the meniscus. And then I read the bottom of the meniscus. So you can see, well, kind of see, that that's 79 milliliters of water, right? Now you might think that that whole container, this thing right here, holds a liter. It doesn't. It's 100 milliliters. And 100 milliliters is not a liter. Remember, millimeters 1/1000. So you have 100 out of 1,000. Everyone okay? Let's see if I can get this camera stood back up. So this is a container that you've seen before. That's a 2-liter bottle. What I'm saying is that if this thing was full to 100, I could fit 20 of them in here, because you can fit 20 times of 100 milliliters into 2 liters, because 2 liters is 2,000 milliliters, right? So this one would be something that would contain liters, right? So that's for liquid volume, right? Next thing that I might want to measure, oh, I forgot to say what we use in English. We use the gallon. And you probably knew this, but a gallon is bigger than a liter. It's even bigger than 2 liters. So I think when I read the sign in the bathroom, it says it's something like 1 liter per flush, or 1.06 quarts or something like that. So not positive on that conversion, but there's 4 quarts in a gallon. So you know a liter is substantially smaller than a gallon. But in English, we use gallons. We have a whole bunch of liquid measurements in English. Okay, and then finally, you can measure mass. Right, and if you want to measure mass, you want to use a balance to do that. And we have 3 different types here that I'm going to show you. And they measure grams. That's the base unit. But more commonly, you're actually going to want to measure kilograms, because like I already said, a gram is like a paperclip. So that's very small. So most things that we're going to use a prefix kilo to measure 1,000 grams or kilogram. And then in English, we use pounds. Right? Well, fun fact for you. Grams are a measure of mass. So really, if you're going to try to find how many grams or kilograms something has, you're actually massing that. That's the verb. I want to mass that item. We don't really weigh it, because weight is something different. But pounds are technically a unit of weight. We don't really use mass that much in English. But just so you know, grams are mass. They're for measuring the mass, which is the amount of matter in an object. And we use a balance to do that. So walk with me over here. I've got some different ones. So this one here is the quad arm balance. That's because it has 4 arms. So you throw your thing in a little basket here. We've got some electrical tape. And then I got these sliders that I can move. So if I think it's maybe like 30 grams, I'll move the 10 slider over to 30, and you can see that it tipped, so that's not right. So I got to back it off to 20. It's more than 20. It's less than 23. It's more than 22. It's about somewhere in that neighborhood. A little more. But 22.5 0.25 grams is the electrical tape. So that's a little tedious to use a quad arm balance. Sorry about my camera work. Right over here, we got the double pan balance. I like them a little better. So you just got the two pans, and then again, you just move the sliders over. Always put the thing you're measuring on the left side so that you can slide to the right to bring it into balance. So as you slide to the right, it comes into balance. Now what I like about the double pan is if something is heavier than what this thing will do, we can just add some known weights over here on the right side. Okay, but my favorite, and probably yours, is the electronic balance, which is this guy right here. And I don't know if you can see, but a little glare. I got one paper clip on there, and it's 1 gram. So that's a little quicker to read. All right, so we're doing this activity today, which there you can see it. It's called metric estimation. So all you're going to do is you're going to go through number 1 through 14, and you're going to try to estimate like how many milliliters could fit into a baby food jar or into a styrofoam cup, so on. And by estimate, I mean just give me a reasonable number, right? Now, if you have the ability to actually look it up on the internet, or you have that item at home and you have some way to measure it at home, you can try to come up with the real answer. If you're in person, I can give you those real answers. And then the bottom here, you're just trying to tell me what unit you would use. So I want to go into the prefixes really quickly so that you can be more familiar with what prefix you should put in front of those base units. Okay? This is actually why we use the metric system. See if I can get my camera to stand up. I'm just kind of learning this whole webcam thing. It's going pretty well so far. All right, we're standing. We're kind of pointed at the board, somewhat. There you go, I like that. Okay, so I've got these base units, meter, liter, gram, and I want to use some prefixes. Now, prefixes go in front of a word, and they modify it. And in the metric system, the prefixes are going to multiply by 10, by 100, by 1,000, or divide by 10, by 100, by 1,000. So they're going to make something bigger or smaller by adding that prefix. They're not the same size. So the prefixes you have to know for this class are kilo, hecta, deca, a base unit, which is a real thing, like a meter is a real thing, so we have to hold the spot for that. Deci, centi, and milli. Okay, so a kilogram just has this prefix kilo in front of the base unit, and it is not the same as a gram. It's 1,000 grams. A centimeter has the prefix centa in front of the word meter. All right, and you can see because it's to the right of the base unit, it's actually smaller. Anything to the left would be bigger. Anything to the right is smaller. So this is 1/100th of a meter, smaller than a meter. A milliliter is 1/1000th of a liter, smaller than a liter. So you just add that prefix, and then it makes it bigger or smaller. So again, if you go to the left, you're making it bigger. If you add the prefix to the right, you're making it smaller. Every move you make in these prefixes is like a power of 10. So in other words, to go from meter to decameter, it's 10 times bigger. A decameter is 10 meters. Hectometer is 100 meters. A kilometer is 1,000 meters. If you run cross country, you do 5 kilometers. That's 5,000 meters. Right? When we go to the right, we're getting smaller. So this is 1/10th of a meter, 1/100th of a meter, 1/1000th of a meter. So an easy way to convert in the metric system, and I don't even really call it converting, when you add these prefixes, all you're really doing is you're just moving the decimal. So you count how many places you're moving. So like if I want to from kilometers to centimeters, I'm going to move 1, 2, 3, 4, 5 places to the right in my list of prefixes, and that means that I need to move the decimal 5 to the right, right? That's like adding 5 zeros. It's the same thing as multiplying by 100,000, right? If I went 5 kilometers in my cross-country race, it would be silly to measure it in centimeters, but that's really a 500,000 centimeter race, right? So today we're having the 500,000 centimeter race. That's really what it is. So 500,000 centimeters is the same as 5 kilometers. We're going to do a lot of that converting from unit to unit in the metric system. And the reason we're going to use the metric system is because you got to learn these prefixes, kilo, hectodeca, unit, deci, centi, milli, and I'll show you some tricks for that. But then once you know them, you're just moving the decimal. You don't have to memorize all the stuff we have to in English, like there's 5,280 feet in a mile, or that water boils at 212 degrees Fahrenheit, or that there is 16 tablespoons in a cup, or I think it's 2 bushels in a peck or something. Anyway, in English, we have all these units, and they have all different conversion factors, 12 inches per foot. In metric, they don't have different numbers to memorize. Everything is just 10 times, 100 times, 1,000 times. So we will use the EVEL metric system. So good luck with the first assignment today, and have a great day, and let me know if you have any questions.